Okay, so in this video I'll be doing Statistics 3 paper, June 2007, and I wouldn't be categorizing my videos according to the papers, rather I'll be categorizing them according to the questions that I'm doing. So today we're going to be doing Spearman's rank correlation coefficient question, and that's the first one. So let's begin. Question 1, part A asks you that calculate the Spearman's rank correlation coefficient for the marks awarded by the two judges. So to calculate the rank correlation coefficient, what you're going to have to do is understand that this is based on rankings, not on ordinal values. You're going to have to make this table, convert this table into rankings. You're going to have to see, for instance, which display is awarded how much marks out of 30 by the different judges. And then you're going to rank those according to the marks, and you're going to find the difference between the rankings. So to rank them, you're going to have to draw another table according to how much marks they are given. So there's a display. Display is A, B, C, D, F, G, and H. So these are the displays. Now you're gonna rank them according to the marks they are given by the two judges. Judge A assigns, Judge B. So let's look at to rank them. You're gonna have to look at how much marks is assigned to which display. The highest marks Judge B assigns is 25, and that is assigned to display A. Okay, actually never mind. The highest marks assigned to 28 to display E. So that's number 1. That is ranked number 1 by the judge. Highest marks are given to display E, so that's ranked number 1. The second highest are given 25 by Judge B to display A, so that's rank 2. 25, is it 24? No, that's 23, and that's D. D is ranked 3rd. And then there is 21, that's 4. Rank 4 to C. Then there is 20, that's H, that's 5. And then there is 19, that's B, that's 6. And second lastly you have F, which is given 17 marks, so that's 7 ranking, and G, which is the last ranking, 8. There are 8 total displays. Similarly, you do the same thing for Judge Q. Judge Q is a little bit harsher, considering that the highest marks he assigns is 21. But anyway, that's besides the point. You're just looking at the ranking they are given. Judge Q gives 21 marks to C, so that's number 1 rank. And Judge Q gives 20 marks as the second highest to A, that's number 2 rank for him. Then you have E, which is number 3 ranking. 17. Below 17 you have 15 marks, that's H, that's the number 4. Then you have 14 marks. Then you have 14 marks, F, that's 5. Then you have 13 marks, that's D, that's 6. Then you have 11 marks, that's G, that's 7 ranking. And then you have 9 marks, that's ranking 8 to B. Now these are all the rankings they are given. Now to calculate the Spearman's rank correlation coefficient, you're going to have to find the difference between these rankings and square the difference. Alright, so let's make another column for the difference squared. Okay, the difference between display A, they are both ranked by both of the judges. Display is ranked on number 2, so there's no difference. The difference between display B is 2. Judge B ranks as 6, Judge Q ranks as 8, so that's the difference of 2. And you square that, you get 2 squared is equal to 4. Then for C there is a ranking difference of 3, so 3 squared is 9. Similarly for D, ranking difference of 3, so that's 9. For E, there's a ranking difference of 2, 2 squared is 4. For F, again, 2 difference, so square is 4. 1 difference for G, square is 1. 1 difference for h, score is 1. And now what you're going to do is sum all the d squared. First of all, you're going to remember the formula that you need in order to solve for the correlation rank coefficient. The formula is something like 1 minus 6 sum of the different squares, and now I'm not quite sure what it is. Let me check it out. This is the formula: 1 minus 6 sum of d squared over n squared minus 1. So in our case, it's going to be n is a sample size, which is 8. 1 minus 6 sum of d squared. So d squares we have found out. You just gotta sum these. If you sum this all, what you get is 4 plus 9 plus 9. Let's just do it here, okay? 4 plus 9 plus 9 plus 9 plus 4 plus 4 plus 1 plus 1. Now this is all over the sample size 8 squared, which is 64, minus 1. If you calculate this, you're gonna get, let's see, 4 plus 9 plus 9 plus 4 plus 4 plus 1 plus 1 multiplied by 6, that's 192. That's 1 minus 192 all over. So you have, oops, my bad, this one is out. The one is not considered with the fraction. So you have 1 minus 192 over 504. And that's 13 over 21. In the decimals, that's 0.619 to 3 significant figures. So that's your correlation rank coefficient, 0.619. That's pretty strong actually. There is some agreement.